Hello everyone, welcome to our presentation. This is Nipa Anjum from Khulna University of Engineering and Technology, Bangladesh. So, I am going to present our work today. Our paper title is EczemaNet, a deep CNN-based eczema diseases classification. Here is the author list of our paper. These are the topics I am going to discuss about. So, eczema is one kind of skin disease. This is usually detected manually by dermatologists. There is a variation in eczema type that makes it difficult to detect. The challenges that we faced working on this disease classification were collecting a proper dataset and then developing a model with great result. Now comes the motivation for this work. It is hard to get better result while working on medical images, and it is also difficult to get large datasets. For any disease classification, we need a reliable system. So, we get the motivation to make such a system for eczema disease and also present a new dataset. We have found that research on eczema disease classification is comparatively less than other researches on skin disease and skin cancer. Among those great researches, we found that the dataset for eczema disease was not that much sufficient, and it is known to us that datasets help us to acquire better performance. These are some papers we used in our researches. Now I will show the methodology of our research work. This is our workflow. At first, our collected dataset was pre-processed and some augmentation techniques were used here. After that, we splitted the dataset into two sets. Here, 80% was for training and 20% was for testing. Finally, we trained the model and evaluated with this dataset. So the images of eczema disease were collected from different sources. Some images were collected from different hospitals in Bangladesh, and some are taken from online. Our dataset contains eczema steatoic, eczema chronic, eczema fingertips, eczema nomular, and eczema subacute. These 5 different types of eczema images. As these images were of different size, we resized them and then applied data augmentation, which gave us 2500 images. These are some samples of our dataset. These are some augmentation techniques we applied to increase our dataset artificially. As we know, deep learning wants more data. That's why we increased our dataset by applying augmentation. So, these augmentations helped us to get more variation in the dataset. It also helped us to avoid overfitting of our model. As you can see, we have applied rotation in both left and right side, horizontal sweep, shading, translation, and shading. Now our model description. Our EczemaNet has 3 convolution layers. We used 224 into 224 with 3 channels as input shape. Batch normalization and dropout were used as regularization methods. Here 50% dropout was used. We used 3 convolution layers containing 32, 64, 128 filters respectively, and the kernel size was 3 into 3 for all convolution layers. We used the activation function ReLU in each convolution layer. Finally, we compiled the model with Adam optimizer and categorical cross entropy loss function. In the output layer, we used softmax activation function. This table here shows the input shape and parameters in each layer. Transfer learning is one of the most popular approaches in deep learning. We also used transfer learning. Inception v3 and MobileNet v1, these two pre-trained models were used here. These models are trained on large ImageNet dataset and work very well with natural images. Pre-trained models decreases the computational power and saves time for training the model. Here, this table shows all the details of these two pre-trained models and our proposed model. This is the graphical representation of the confusion matrix of our EczemaNet. The columns and the rows indicates predicted levels and actual levels respectively. We calculated the true positive, false negative and true negative values using these equations. For measuring our model's performance, we calculated sensitivity, specificity, accuracy, false positive rate, and false discovery rate. These are the results of 5 different classes. This is the performance comparison table of Inception v3, MobileNet v1 and EczemaNet. Here, sensitivity, specificity, precision and accuracy is shown. We can see EczemaNet has 90% sensitivity, 97% specificity, 90% precision and 96.2% accuracy on our dataset, which is the best among these 3. So here is the performance explorations part. These are the graphs of accuracy and loss of our proposed EczemaNet. Both are regarding training and validation. Figure 5 shows the training progress as processes of accuracy. Here, the blue line that specifies how well the model performed on the training data, and the orange line specifies the model performance on validation data. The x-axis indicates each epoch, whereas the y-axis shows the increased accuracy. Same as the loss graph, blue line and orange line represent the training and validation set respectively. Here, the x-axis indicates each epoch, whereas the y-axis shows the decreased loss. This one is for Inception V3. Here, the graph of accuracy on the left and cross entropy on the right that has been created in the tensor board. Here, the red line representing the training set and the blue line representing the validation set. We used 4000 steps to achieve this accuracy. And the last one is for MobileNet V1. Here also, the red line representing the training set and the blue line representing the validation set. In MobileNet V1, we used 5000 steps for achieving the accuracy. The main contribution of this work is the presentation of a collection of new datasets on 5 different types of eczema diseases, and then the development of a state-of-the-art EczemaNet model. So, in future, we would like to improve our model by adding some more features to the classes and enhancing the number of classes to facilitate more image processing techniques. We will also use some segmentation techniques to improve the result that will make the system more reliable to detect eczema diseases within a short time. It will help our doctors to treat our patients more better. These are some important references that we have used. Our affiliation and acknowledgement. That's it. Thank you for your attention. This is the end of my presentation.